Hello, my name is Samson and this is Chemistry with Samson. If this is your first time visiting our channel, please don't forget to subscribe to our channel and share and like our lessons if you find our lessons educative as well. In this lesson, we are going to discuss one type of intermolecular bonds known as the dipole-dipole interactions. The dipole-dipole interaction. A dipole-dipole interaction arises when two polar covalent compounds are brought near each other. It is a type of intermolecular bonds that exist between polar covalent compounds. Is that okay? So for example, if I have a polar covalent compound, HCl, this is a covalent bond taking place. In order for me to identify this as a polar covalent compound, I should indicate the partial negative sign on the most electronegative element and the partial positive charge here. In our previous lesson, I said a dipole arises whenever we have separate charges on the species involved in the bond. A dipole arises as a result of polarity. Is that okay? So we have a dipole arising here. If we have another polar covalent compound, let's say HCl, again, this is partially negative and this is partially positive. Again, a dipole will arise in this as well. The dipole that arises in this HCl is permanent. It does not change because of the electronegativity differences, which brings about the partial negative and partial positive charges on the atoms involved in a bond. So this is a permanent dipole. The dipole here does not change. It is always the same, and it arises due to the polarity introduced in a covalent bond here. So if I have one polar covalency or one polar covalent compound here and another polar covalent compound here, in which dipole arises in them, once they are brought near each other, they interact through what we call the dipole-dipole interaction. And it's a weak intermolecular bond. Is that okay? So this one here and this one here, there's going to be an attraction between this partial negative charge and this partial positive charge. So this attraction between this and then this one here, this is a molecule. This is also another molecule, a compound. So between this and this, intermolecular, particularly a dipole-dipole interaction. So we have a dipole-dipole interaction existing between two polar covalent compounds. Is that okay? A dipole arises as a result of polarity. So partial negative charge on the most electronegative one and a partial positive one on the most, with the one which is deficient in electron. Is that okay? The less electronegative element. So once the charges are being placed here, a dipole arises out of this polarity. So if you have another polar covalent compound up nearby, due to the charges on the individual atoms in the polar compound, they are going to interact through what we call the dipole-dipole interaction. They are going to interact through what we call, again, the dipole-dipole interaction. And this dipole is a permanent dipole. So we can also call this a permanent dipole-dipole interaction, because this dipole arises as a result of electronegativity differences, which introduces the polarity in a covalent compound. And it does not change, it is permanent. Is that okay? So the partial negative charge on the chlorine will always be the same, it won't change, because this is more electronegative than the H here. So the dipole that arises here is not just any dipole, a permanent dipole. So there is a permanent dipole here, there's also a permanent dipole here. So we can also call this a permanent dipole-dipole interaction. And it takes place between two polar covalent compounds brought near each other as a result of polarity, which introduces a dipole in their system. That is dipole-dipole interactions. Dipole-dipole interactions.